Alright, so now we're doing linear equations. We're going to do what's called standard form. So an equation is in standard form if it is written like this: a number times x, a number times y equals c. Anything that can be written like that gives us a line. If it cannot be written like that, then it gives us some curved thing that's nonlinear. Alright, so the things that will produce a nonlinearity are things like an exponent. Alright, things like multiplying a variable times a variable, that will not work. And then dividing by a variable. Alright, so here we're dividing by an x, and that produces a nonlinearity. Alright, so let's show you these three right now. So we have the multiplying two variables, the exponent, and the dividing by a variable. If we look at this, here is the multiplying two variables. So I just plug that equation into Grapher, and it produces a clearly nonlinear function. It's not a line. If we have an exponent there, that gives us this. Alright, so that's not linear. Dividing by an x, it may be hard to see, but that is 2 divided by x. And that looks like this, so not linear. Alright, so those are all nonlinear functions. The other ones can be converted into standard form because it's just either one variable or two, but you're never multiplying, there's no exponents, and you're not dividing by a variable. This is a special case that I'll show you at the end. Alright, so let's write it in standard form. Subtract 4y from both sides, and that gives us 2x minus 4y, and 4y minus 4y. What are we left with? Just 0. That's fine. So we still keep it an equation, right? We have to have something over here. It's a 0. So 2x minus 4y equals 0. That's standard form. Alright, we're almost in standard form, but we don't want a number alone here. The lone number is on the right. So that gives us y equals 2. Well, that's certainly a line as well. Alright, so let's graph both of these. I plugged in the original form. 2x equals 4y. That's a line. 6 plus y equals 8. That's a line as well. Okay. So linear, linear. This is already in standard form, so we don't even have to do anything. Number times x, number times y equals a number. Standard form already, and that is a line. Just to show you, that's what it looks like. Alright, so we have, this is like a 1 times y, a number, fractions are numbers too, a number times x plus 5. Alright, so it's not standard form, but it is linear, so we have to, because there's a fraction here, that's the other thing with standard form, they can have no fractions. Okay, so if this one's got a fraction, we got to get rid of that denominator. So the way we do that is, because it's a 4 on the bottom, I'm going to multiply both sides by 4. Alright, so now I have 4y equals, I gotta distribute this to both. 4 times negative 3 over 4 is just a negative 3. 4 times 5, that's an x there, I'm sorry. And then 4 times 5 is 20. Now we just have to add the 3x to both sides, and we get 4y plus 3x equals 20, standard form. Alright, this one technically would be linear, except for we're not allowed to use 0 in the domain because you can't divide by 0. But if we multiply both sides by x, then that cancels and we have y equals 3x, which is a linear function, right? That's a direct variation function. If we move the 3 over, then we got a negative 3x plus y equals 0. So that's standard form, except for we can't use 0 in the domain. We don't really need to worry about that for this course. Alright, so standard form, just like this. Okay, now we want to talk about the intercepts. That's where it hits an y-axis or an x-axis, and we can use that to graph, or we can take this form and transform it into slope-intercept form. Alright, and graph it the way we know how to graph something when it's in y equals mx plus b form. So there's two methods, and you're going to have to learn both. Alright, we want you to know how to do all of them. So the x-intercept, if this is my axis, if I'm on the x-axis somewhere, right, I don't know what the x-coordinate is necessarily, but I know that the y-coordinate has to be 0. Alright, so that's some useful information. So if I know the y coordinate has to be 0, I can plug in 0 for y. And then for the y-intercept, I know that the x-coordinate has to be 0, whatever the y-coordinate is. All right, so I'm going to use that for this method here. Now what I do is I literally would, if I was doing this in front of you on the board, I would take my hand and I would cover up the, I'll show you what I'm talking about. Not red. So I know for one of my intercepts the x is 0, I know for another intercept y is 0. So when I'm doing by the intercepts, I automatically write this right off the bat because I know it's going to have a 0 for an x and a 0 for y for the two different points. So what I would do is if I'm plugging a 0 in for x here, so 2 times 0, that's the same as 2 times 0 is just 0, so really I'm just solving the equation 4y equals 8. So if 4y equals 8, then y has to be 2, right? And if I'm plugging in a 0 for the y, then I know that I take my hand, I would literally, or my finger, and I would cover this one, and I have the simple equation 2x, because the 0 has canceled that term, 2x equals 8. So x has to be 4. Oops. So those are my 2 points. So I can just graph it right now. I have 2 points. That's all I needed to graph a line. So there we go. 0, 2. And 4, 0. So there we go. There's my line. All right. Method 2 is getting it into slope-intercept form. So let me grab this equation, put it over here. What I got to do is first get the x over. So I have 8 minus 2x. What's 8 minus 2x? Well, it's 8 minus 2x, right? Can't combine these. And I'm going to write it, to keep it looking more like this form, I'm going to write the x term first. So minus 2x plus 8. All right, the sign stays with the term. So minus 2x and the plus 8. Whoa, my bad. Now I divide by 4 everywhere. So if I divide the left by 4, I have to divide everything on the right by 4. So that gives me y equals negative 2 over 4 is the same as negative 1/2 x. 8 over 4 is 2, so plus 2. So my y-intercept is 2. And then my slope is negative 1/2. So down 1 over 2. Down 1 over 2. Right? You guys know how to do that. And it gives us the exact same line. Alright, so you got to know both methods. So let me show a few of the different little quirks or whatever that can happen with these. So to find the intercepts, right off the bat, first I want to put it in standard form. So I have to minus the 4y. And that gives me 3x minus 4y equals 12. So then I am going to find the intercepts. So right off the bat I do this. If x is 0, I plug it in here. 3 times 0 is 0, so that eliminates that term. Negative 4y equals, negative 12, my bad. Negative 4y times y equals negative 12. Y has to be 3. And then if I plug in a 0 for y, 4 times 0 is 0. So I'm really just solving the equation 3x equals negative 12. So 3x equals negative 12. X has to be negative 4. So I can graph those 2 points now. 0, 3, negative 4, 0. All right, and now to get it into slope-intercept form. So we subtract the 3x, and we got negative 4y equals negative 3x minus 12, divided by negative 4. And that gives us y equals negative 3 over negative 4 is the same as a positive 3/4 x. Negative over a negative is a positive 12 over 4 is 3. And we got exactly what we should, same thing. Y-intercept is 3, and then up 3 over 4, or continue the pattern backwards, down 3, back 4, same line. Okay, So here, I'm going to get the intercepts. And the reason I showed you this one is the intercepts don't work out to be nice, pretty clean integer numbers. Okay, so if I plug in 0 for x, I'm doing 2y equals 8, so that is y equals 4. Alright, and then if I'm doing the x-intercept, I plug in 0 for y and divide both by 5. I get 5x equals 8, so 8 over 5. So x equals 8 over 5. So that's my intercept here. So that's not a very easy one to graph. So I did find my intercepts, and I'm in standard form, but 8/5 is kind of hard to graph on here. So this is when it's a good idea to be able to get into y-intercept form, or slope-intercept form. So it's my 5x. I got 2y equals negative 5x plus 8, divide by 2. And I got y equals negative 5 halves x plus 4. So my y-intercept is 4. I'm going to go down 5 over 2. There's my line. Alright, this one is easy. It's already in standard form. It's a line x equals 4. You should know this from before. Alright, so its x-intercept is 4, 0. There is no y-intercept because it never hits the y-axis, and it's already in standard form. It's already in slope-intercept form, if you want to call it that too. Here, they're both set equal to 0, so if I try to get the intercepts, plug in 0 for x, divide both by 3 here, and I get y equals 0 for my intercept. If I do it with the for the x, so I plug in the 0 for y, divide by 2, and I get 0 again. Okay, so that's the same point. So I know this point's on my graph, but it didn't give me two different points, so I can't really graph it. So you're going to do the y equals mx plus b form. So minus your 2x. And we get 3y equals negative 2x. Divide by 3. So I have y equals negative 2/3 x. So my intercept is here, and then down 2 over 3. Or continue the pattern up to back 3. Alright, so that's all that you have to do. Now you got to watch the other video to do the application, but this is just the nuts and bolts. Alright, so here are the U-tries. Alright, very similar to what we did before. These, I know there's like 6 problems here, but they're actually really pretty quick and easy. And if you have any questions or comments for next class, make sure you write them down on the side or something somewhere, and we'll talk about it. Alright? And don't forget to watch the application video.